I will give you guys 2 minutes for this. Yeah, the answer. 30 more seconds. Got a few answers now. Yeah, the has only answered. Okay. So it is saying haloalkanes react with KCN to form alkyl cyanides as a main product, while AgCN form isocyanate as the main product. I mean, I hope you remember that this is true because when you have Rx, it will react with KCN, and because KCN is ionic, it is associated positive and Cn negative. Now, here the attack can be from the carbon atom as well as from the nitrogen atom, but since carbon is more nucleophilic, that means carbon-carbon bond is going to be more strong. That is like what will happen. It is going to bond with R, and it is bond like this, RCN. Now, if you have Rx plus you have AgCN, then please remember AgCN is having a highly covalent nature, and that is why the attack can only be possible from nitrogen atom. Carbon atom cannot attack. It does not have any lone pair. It is not nucleophilic at all. So the reaction will give you a product which is RNC. So this first statement is true. But the second is both ionic because AgCN is not ionic, and that is why it gives isocyanate. Okay. So AgCN is covalent in nature. Can you please copy this down? Okay, this is ionic. This is covalent. So which statement will be correct? The assertion is correct and the reason is not correct. So A statement will be correct. I hope this is not new for you guys. Maria, tell me, is this new for you?
Yes, sir.
Yes. Okay. What about you, Iyad?
Yes, sir.
Achha, it is new. Achha, theek hai. Now what I would do is see, I mean, but it is generally taught na in hierarchy. So what I will do now na is see actually I have taught. That is why I think Tarif and Shahid tell me. You remember these from notes?
Yes, sir.
Fine. So what I will for Maria and Iyad, I will send you guys the notes. Okay. So once you get the notes, you can. This is one of the major topics. Also, like, remember anything regarding alcoholic KOH and aqueous KOH? Maria, Iyad, tell me how haloalkanes react with alcoholic KOH and aqueous KOH. Yes, ma'am. No. Iyad, aqueous KOH, alcoholic KOH. No, it's not GOC. It's haloalkane halorine. अच्छा, ओके ऑर्गेनिक केमिस्ट्री में आपका थोड़ा सा ये है मारिया व्हाट अबाउट यू
Yes, sir. Could you repeat?
डू यू रिमेंबर एनीथिंग अबाउट aqueous KOH and alcoholic KOH
When aqueous KOH reacts with haloalkane, it gives
हम्म
alcohol.
हम्म
While when it reacts with alcoholic KOH, it gives an alkene.
alkene हाँ that is fine but you did not remember anything about KCN AgCN and like also one more thing.
Sir, I actually joined right now, so yeah, I was getting
नहीं
ready.
नहीं no I'm not saying that but from 12th class syllabus do you remember these things
Yes,
no
sir.
अच्छा KCN AgCN you remember okay fine. ठीक है, but I will ask the team ना to send you the notes of organic chemistry class 12. So if you have like you at least you would read and come to the class. ठीक है. चलिए. अच्छा, when I was asking ना, is this new for you? I meant to say that KCN is. I hope that's not this, na, Maria.
Yes, I'm familiar with the
You have
concept.
seen this before. You're familiar with the concept. Okay. Iyad has a Iyad. It is new for you, right? Iyad.
Yes.
ठीक है, fine. So I will ask the team to send you the notes. Try this now. Not just so huge, just something small like this. Please see that you have only concentrated HNO3 there. Okay. In the first step, you have only concentrated HNO3. Second step, you have NaOH and then HCl. You can give me 2 minutes for this. Okay, so the time is up. I've got three answers. Yes, the two answers are correct. Maria and Tarif. That's fine. That's correct. So when you have concentrated HNO3, uh, all the ortho and para positions of the bromobenzene is going to be attached with NO2. And once it is attached with NO2, it will uh, weaken the bond of bromobenzene. And what would have the nucleophile NaOH attacks? The OH can attack on carbon which is having bromine atom. And that is why the bromine will leave, you will get OH in place. So see that top. Okay. See, moving on. Try this. So you have first of all alcoholic KOH, then you have HBr, and then you have aqueous KOH. Take 3 minutes for this. This will take a bit of time. Okay, two answers. You guys have 1 more minute. Okay, Taris. The time is over. First of all, you have three carbon atoms and then Br. So we have 2, 3, and then we have Br. In the presence of alcoholic KOH, it will go under elimination. Br will leave from this carbon and one hydrogen will leave from the adjacent carbon, and we will get a alkene like this. Now they are saying that we are going to attack this with HBr. And when we do the attack with HBr, then what will happen? H plus and Br negative. So Br negative is going to get attached on the alkene, and it will attach on the carbon atom which is having less number of hydrogens. So negative part of the reagent attaches to that carbon atom which has less number of hydrogen, right? So the Marconic you will have And after this, when we react this with alcohol, sorry, aqueous KOH, then this Br will be replaced OH. So we will get propane 2-ol. And that's the option number C. So you guys were right. This is the correct option, propane 2-ol. Nice. आराम से सवाल को पढ़िए. Please don't look at the length of the question and decide whether to do it or not. ठीक है, आराम से पढ़िए सवाल को, हो जाएगा. Take 1 more minute. Okay, let us see. The first statement is saying high concentration of strong nucleophilic reagent with a secondary alkyl halide which do not have bulky substituent will follow SN2 mechanism. Okay, so it is saying that if it is not having bulky, then obviously it's very obvious that if it is not having bulky substituent, then it is going to follow the SN2 mechanism because SN2 is facilitated if you don't have any hindrance. So this will be true. And it will be also true because high concentration of strong nucleophilic reagent. So whenever we have a strong nucleophilic reagent, that means we have strong nucleophilic reagent. What will be strong nucleophilic reagent? It will be having a charge on it. For example, if you have, let us suppose what, CN negative, you have OH negative. So these are what they are going to be classified as strong nucleophile. And these strong nucleophile, they are able to attack on the reagent. And the attack on the reagent, sorry, the attack on alkyl halide, it happens only in what? SN2. The attack on carbocation happens in SN1. Okay. Attack on carbocation happens in SN1. So this statement is true and it does not have any bulky reagent, bulky substituent. That's why it's going to follow the SN2 mechanism. The secondary alkyl halide, same here also we have a secondary alkyl halide. When treated with large excess of ethanol, ethanol is not a strong nucleophile, it is a weak nucleophilic reagent. Why it is weak? Because it is not having any charge. ROH, it has to attack from the lone pair electrons. It will follow SN1. So this is also true that it is because it is weak nucleophile, it is going to wait for the secondary haloalkene to first of all get loose of the halogen atom, form a carbocation, and once it forms carbocation, then only this ROH is going to attack on the carbocation. Okay, it's going to attack on this carbocation. So both the statements are true, and that is why statement 1, statement 2 both are true. तो ये ध्यान रखिएगा यहाँ पे that if you have strong nucleophile, then it is going to be majority of the time it is going to be SN2, and if you have a weak nucleophile, then it is going to be SN1. So this is also quite easy. Example of vinylic halide. Take minutes for this. Vinylic halide पूछा है vinylic. And more seconds. So let us now classify a few things. When you have haloalkene or halorine, yeah, fine. So when you have haloalkene or halorine, the haloalkenes are divided into, and basically monohaloalkene, they're divided into two categories. Some of the haloalkene, they will be connected to sp3 carbon, and in some cases, the halogen atom will be connected to sp2 carbon. So when it is connected to sp3 carbon, it is alkyl halide. Now, alkyl halide, it has various categories. It is 1 degree, 2 degree, or 3 degree. Then it can also be one more thing, that is allyl halide or allylic halide. And allylic halide, it looks something like this. You have sp2 carbon atom, which is connected to sp3 carbon atom, which is connected to a halogen atom. So it looks something like this. You have carbon, double bond carbon, then you have CH2 halogen. So you see halogen, sp3, and then double bonded. Similarly, you have sp3 mehi, one more classification, that is benzyl halide, in which you have the benzene ring, which is connected to a sp3 carbon, further connected to a halogen. In sp2, there are only two categories. We have vinylic. Vinylic is sp2 connected to halogen atom. So example would be carbon double bond carbon, that is directly connected to a halogen atom. Halogen atom, uske baad turant carbon double bond carbon. And the other one is aryl, which is you have benzene ring, and then in benzene ring, the halogen atom is directly connected. So it is an example of aryl. Now, what we have to see, we have to see the vinylic. So vinylic will be sp2 directly connected to halogen atom. So you will see the first option here, halogen directly connected to the carbon double bond carbon. So this will be correct. Now let's look at the next one. Here we have halogen atom, then we have sp3 carbon, CH2. Then we have the double bond carbon atom, so it is going to be allylic. Now let's look at this one. This is going to be aryl, because halogen atom is directly connected to the benzene ring. In the fourth option, if you see, we are having a halogen atom, then we have this is sp3, which is further connected to sp2. So this is again going to be allylic. Okay, so correct option is the first one. Vinylic is the first one. Please copy this down if you have not seen this previously. Nice. Fine protein percent. Again, take 2 minutes for this. I mean, this includes a few more things apart from halogen and haloarenes. Okay, Shahan. Okay. PC. So in the first step, what is happening? We are having a benzene ring with B. When you add the Mg, this is going to give a Grignard reagent where you have GBr attached to benzene. Now, once you are going to react this with CO present H plus, then what's going to happen? The CO2 will be attacked by the benzene ring because CO2, it is like this linear, and this carbon atom, it is connected with 2 oxygen atoms, which is very electronegative, and that's why it will have a highly positive charge. This highly positive charge will be attacked by the benzene ring and it will form COO negative. This MgBr will be leaving, and after H plus, you will get COOH. Now, once you get COH, then you have to treat this with ammonia and heat it. So this is an acid, this is a base. Ammonia it is having a lone pair electron. So it is going to form a salt, but after heating, the salt will form C double bond O NH2, that is the amide. After this, we have Br2 in the presence of NaOH. So this is actually Hoffman bromamide degradation. So this is amide, and you are adding bromine and NaOH. So it is going to remove the CO, and you will get NH2. Okay, so this option is in C option. So C option is correct. Please write this down. This is till here. All of these are in NC. I mean, all of these are boards level. Till here, you have in method of preparation of carboxylic acid. This is a reaction of carboxylic acid, and this is in amine. Okay, method of preparation of amines. Hoffman bromide. Mhm. Try this. Again, something we have already done. ये I think हो जाना चाहिए आप लोगों से. One more guys. Got two answers. ये होना चाहिए गाइस. अभी हम लोगों ने पढ़ा है अलाइल विनाइल एवरीथिंग. 10 more seconds. Easy. So the first statement is saying we have halogen, then we have sp3 carbon atom, we have sp carbon atom, and this is an example of allyl halide. This is true. Allyl halides are compounds in which halogen atom is attached to the sp2 hybridized carbon. This is going to be false because it is attached to halogen atom, sp3, not sp. So the assertion is true, reason is false. Option A. Is cut into isocyanide by the reaction with. You have seen this. The first question it's alkyl isocyanide. शाहिद जी. Like we have seen this ना. KCN से क्या मिलेगा साइनाइड और HCN से आपको मिलेगा alkyl isocyanide. Option D. I'm going to give you guys 2 minutes. ठीक है. This is also something we have done. बट आपको पता याद है कि नहीं याद है? नॉट नाउ ऑब्वियसली, बोर्ड्स में इस तरह के सवाल भी हैं। Ten more seconds, guys. Yeah. Analytes cannot be prepared by replacement of hydroxyl group of halogen ion. Let us see whether the statement is true or not. So if you look at replacement of OH, we cannot remove this. They are saying that we cannot break this OH bond and replace this with any halogen atom. No? So is this right or not? Please see. This OH bond, it will be resonance stabilized. Okay? And this will have what? A partial double bond. And partial double bond, it will be very difficult to break. So even like if we are going to give a very drastic condition of high temperature and high pressure, only then this OH bond could be broken. Otherwise, it cannot be broken and it cannot be formed into the halogen. I mean, it cannot attach halogen here. So this statement is true. The reason they are saying is phenols react acid violently. This is not true. This is false because it doesn't react with halogen acids. Okay. Kind of statement, the appropriate would be true and false. So assertion is true and false. Okay. So why this phenol does not react with chloride halogens? Because of what? Because of the OH bond. And this is also something that we have done. It may be present in your notes. आप अगर देखेंगे इनिशियल क्लास में ही हम लोगों ने इसको किया होगा. Method of preparation of alcohol, and see, the above methods cannot be used for the preparation of halogenes with phenol because phenol exhibit resonance and COH bond is in phenol possesses partial double bond character. Okay, so that is the reason it cannot be used for the preparation of halogenes. Okay, with phenols. बिल्कुल एकदम ऐसी सवाल. चलिए मूवी. Question one, I hope आपको question one थोड़ा सा याद हो, so you can answer. Space. Please try. Take minutes for this. We have got one answer. Which of the following halides will not show SN1? It should not show SN1. The time is up. अब देखिए यहाँ पे भी ना, this is something that done in the board examinations. देखिए फर्स्ट वाले में अगर हम बात करें, then if I am going to remove the Cl, then there will be a positive charge on the CH2 and it will show resonance. It will be resonance stabilized. ठीक है, so it can undergo resonance. But if I remove the Cl, like when what happens in SN, first of all Rx, the X leaves and you have R positive, and then the nucleophile attacks. So this step is what is the rate determining step, whether the reaction will occur or not. If the carbocation is stable, then only the reaction will occur further. Otherwise, it is not going to occur. So A1, in the A case, we are having a resonance stabilized carbocation, so it is going to undergo. What is about B? In B, what is happening? The Cl, if you remove it, you will get a positive charge here, and this CH will be having a positive charge, which is what, which is attached with CH, which is again what, sp2. sp2 is more electronegative, and it will not be stabilized anyhow. Okay, so there will be no stabilization. Also, one more thing is that it will be very difficult to remove the Cl here. Why it will be difficult? Because the Cl is going to have lone pair electrons, and this will show resonance. And when the Cl is showing resonance with the carbon, then there will be partial double bond. Partial double bond makes it difficult to remove the chlorine atom. So this is not going to react. What about if you remove it here from here? If you remove from Cl, if you remove Cl from here, you will get a positive charge here, and it will be 2-degree carbocation, which is quite stable. So the one which cannot do any reaction and it cannot show SN1, it is the B1. B कहाँ पे? B is in the fourth option. अगर option में B and D होता ना किसी option में, then would have done B and D also, because 2-degree it can go SN1 also, and it can undergo SN2 also. ठीक है? So but B वाला it will not go SN1 SN2 कुछ नहीं, ये nucleophilic substitution नहीं दिखाएगा. This is known as alpha unsaturation. Alpha unsaturation में SN1 SN2 कुछ नहीं होता. ठीक है? So I think this is also there in the, this should be there in the notes. Alpha unsaturation. See here, alpha unsaturation always decreases the rate of reaction. ठीक है? So for example, this one, यहाँ पे this is not going to give you SN1 or SN2 in normal condition at least. ठीक है? So whenever you have alpha unsaturation, the carbon that is directly connected to hydrogen, if it is having a double bond, then it is not going to undergo alpha unsaturation. ठीक है? Moving on. ये भी आसान सवाल ही, बहुत ज्यादा हार्ड नहीं है. Okay, I've got two answers already. Okay, then yeah, the correct statement regarding nucleophilic substitution reaction in a chiral alkyl halide. Take one more minute. देखिए टाइम इज अप। SN1 में क्या होता है, यू विल हैव कार्बोकेटाइन, सो व्हेन यू हैव कार्बोकेटाइन then the p orbital is vacant like this. Nucleophile can come from this side as well as from this side. So both are, दोनों में 50-50% chances होते हैं, and that is why you get racemization. But what happens in SN2, you have all the four carbon atoms, एक यहाँ पे Br है आपके पास, the only available attack is from the back side. So nucleophile is going to attack from the back side, and when it attacks from the back side, what will happen? You will have inversion. ठीक है? So this is SN1 and this is SN2. So SN1 में racemization, SN1 में racemization, inversion, retention in SN1 नहीं. Racemization in SN1, yes. Retention in occurs in SN2, no. Retention does not occur. ये नहीं होता है. Racemization in SN1, yes. Retention नहीं. Racemization नहीं, दोनों में नहीं होता. Racemization in SN1, inversion in SN2, yes. The option is correct. Take 2 minutes for this. A few more seconds. चलिए देखिए, this is quite interesting. Please see. ध्यान से देखिएगा. Please don't write anything right now. ध्यान सुनो. What is the difference between the two reactants that we are having? Here we have methoxy group and here we have NO2 group. What is the difference between methoxy and NO2? This is plus M and this is minus M. So what would happen with the plus M group? In plus M group, it gives the electron density towards the benzene ring, especially in the ortho and para direction. So when chlorine, if you are going to remove the chlorine atom, you will get a positive charge here, and this positive charge, it will be stable. That is, this particular reactant, it will favor SN1 because the carbon is getting formed by oxygen. But if it seems here that I give a positive charge here, so this will also be stabilized by the benzene. But that is why it is much better for this reactant to undergo SN2. The nucleophile directly acts here and it goes under the conversion and SN2 reaction. So it does not want to form carbocation because the carbocation will not be stabilized because of the minus M effect of NO2 group. So the first reaction, the reaction first, second order, second is no, this is wrong. Oh, wait, I'm sorry. The reaction first is of second order. No, this is of first order because this is second. No. Reaction one and two both second order. No, reaction is the first order. The second is second order. Whole thing, Maya. Maria from the starting.
Yes, sir, your voice was lagging, so I couldn't hear anything in the beginning.
Oh, yeah. So see, what's the difference between these two reactor molecules? Methoxy, methoxy plus M group, NO2 will be minus M group. Plus M group, it reduces electron density, and if they are going to produce carbon using CL, you will get a positive. This carbon will be stabilized by plus M group because carbon is a electron addition and plus M group will give the electron density and make it stable. So this is will undergo via SN1 mechanism. Whereas second one, we have everything is SN, but we in the paradox. So if I want to remove the atom, we will get a positive charge here, which will now be destabilized by minus M group because charge minus M group. They withdraw pull the electron density, making it even more positively charged. And then what is going this will be quite stable. That is why we don't want to make a carbocation here. We don't want to make a carbocation. First action is nucleophilic substitution. That means there's first order and SN2 is going to be bimolecular. That means it is second order. Okay. So reaction first is first order, reaction second is second. Make sense, Maria?
Yes, sir.
Chaliye, moving on. Try this. Again, it's a long question. It seems long, but आराम से पढ़िए. Let me go. Sorry, guys, I got disconnected. Am I audible properly now, Maria?
Yes, sir.
Okay, please see here, guys. Identify the correct order of reactivity for the following pairs towards the respective mechanism. So SN2 के लिए उन्होंने बोला है that this first reaction will be more reactive than the second one. And I think that is correct. With 1 degree, this is 3 degree. In SN1, it is saying that this is going to be benzyl bromide is going to be more faster than the normal 1 degree. So this is also true. This is true. This is also true. In electrophilic substitution. So in electrophilic substitution, what happens if you have electron, we have seen this previously in the last class. If you have electron donating group, then this is going to increase the reactivity. And if you have electron withdrawing group, then this is going to decrease the reactivity. So in the first case, we have only one chlorine. That means it is still electron withdrawing group, but it is going to decrease the. And the second one, we have Cl as well as NO2. So this is going to decrease the electron density in a much higher way. That is why this is also true. This is correct order of reactivity. In nucleophilic substitution reaction, what happens? In nucleophilic substitution reaction, we have to attack from a nucleophile. And nucleophile is what? It is negatively charged. So it cannot really attack the benzene ring. If you want the nucleophile to attack the benzene ring, it should have some minus M, or rather I should say electron withdrawing groups. So for nucleophilic substitution reaction of benzene ring, what should happen? Electron withdrawing group, it will increase. So this is false. So ABC is true. Do we have any option ABC? Nucleophilic substitution. This is false. This is true. SN1, this is greater, this is true. SN2, 1 degree and 3 degree. This is also true. But there is no option A, B, C. Let me recheck the question. Okay, so the question that I pasted is a bit wrong. So the JEE question is something like this. इसमें D option is also correct. Okay. So from the site where I pasted is a bit wrong. If you see here, the first, this is 1 degree, this is 3 degree. थोड़ा सा यहाँ पे ये भी सही है ना? A few parts are wrong. So this is true. This is the same thing. यहाँ पे आपके पास this is going to be stabilized by the resonance. This will not be stabilized. So this is also true. Electrophilic substitution. This is true. Here we have only one electron withdrawing group. Here we have two electron withdrawing groups. So this will be more reactive. Here we have one electron withdrawing groups. This is also true. So A, B, C, D all are true. Second option is correct. ये यहाँ पे थोड़ा मिस्टेक है, ऐसा होना चाहिए. चलिए, moving on. This. Please see here, guys. The correct order for reactivity of the following are arranged towards nucleophilic substitution with aqueous NaOH. So we have seen that nucleophilic substitution में क्या होना है? Nucleophilic substitution में if you have electron withdrawing group, then the reactivity is going to increase. So the first one it has 0 electron withdrawing group. Here we have 1, and here we have, I mean इसको तो -1 कर देना चाहिए, because here we have an electron releasing group. ठीक है? And here if I see, here I have 3. So obviously D will be the most fastest, and followed by B, followed by A, and then followed by C. So D, B, A, C, B, fourth option. Okay, so electron withdrawing group, if you have, then it is going to increase the reactivity of nucleophilic substitution. Why? Because nucleophile is negatively charged and nucleophile is electron rich. When it attacks the benzene ring should be a bit less electron dense. So moving on, let's try one question. This one like that. The decreasing order towards SN1. SN1 में आपको देखना प्लस एम इफेक्ट. Take 2 minutes for this. We have a few more seconds. See, so the first one is minus m, then we have plus m, then we have again this is plus m, but it is going to be electron withdrawing group, right? So यहाँ पे हम लोग किसको देखेंगे? Minus I देखेंगे. Here we have 0. We don't have anything else. So if you see here, सबसे ज़्यादा it will be B. B will be what? The most reactive towards decreasing order SN1. The most reactive कौन सा हो जाएगा? B. So B is in this which option? Yeah, B option. So this will be correct. As you can see, plus M, then 0, then A, then sorry, then minus I, and then उसके बाद A. ठीक है? तो you have B, उसके बाद D because यहाँ पे कुछ effect नहीं होगा. Then you will have C because here we have minus I, and A will be the least reactive because there we have minus M, B, D, C, A. ठीक है, that is the option. चलिए, so one thing that